Hello guys, it's Adam the Science Student here, and today we're going to be talking about elimination reactions, which is the E1 and E2 reactions. And this is quite different from substitutions. An elimination will occur and an alkene will be formed, or sometimes even alkyne. So for E1 happens in two steps. It's similar to SN1, where two things happen in the one part. So E1 has two steps. On a 2' carbon with a weak base, it needs to be protic. If we remember, a protic is an H bond donor, which is an alcohol group, the nitrogen with the hydrogen, or it could be a 3' with just a weak base. So really just the weak bases happen in E1, and then the leaving group can just pop off. And when it pops off, what is formed? A carbocation would be formed. So this would equal carbocation formed. So, I know I talked to that quick, but we're going to go through some examples. So let's go over E2, elimination 2. So it's one step. It could happen on a 2' carbon or 3' carbon, similar to E1. So you have to be very careful what is it reacting with. And this has a strong base, and it needs a driving force. And it needs a driving force to get it just to pop off and get off. So let's go ahead, pause the video and please erase this, and then we're going to look at two different problems that we can evaluate. So I'm going to get this problem here, which is, okay. So this is going to be our problem. And how can we tell if it's E1, E2, or what is it, and how do we know? Well, as you can see, the leaving group is protic because it has a hydrogen, and anything that has a hydrogen group can be protic. And that's our leaving group, right? It's our leaving group. So let's go ahead and make a note of that. It's orange. It's our leaving group. Here's our base, and is this base strong or is it weak? Well, as we remember from previously, E1, or as we remember from previous videos, this is a weak base, so it'll be an E1, okay? And it is a weak base because it's a stronger acid. So let's draw out this molecule here. So here's the electrons for the oxygen, and what's going to happen, and this is a two-step since we know that it's now E1. So the oxygen is going to grab, the electrons will attack the hydrogen. So then we're going to have something like this. Two plus HSO4 minus. Okay, and this would be a plus charge. This would be a minus charge. Then what we're going to do is we're going to create the carbocation. So this is just a positive charged oxygen, and as we know, that makes a good leaving group. So it's going to kick this off, kick that off, and this is what's going to be formed. So this is going to form the plus, so it's carbocation. It's just the extra hydrogen that's here because carbon has 4 bonds, or likes to have 4 bonds. Okay, so this is what is formed here. So it forms a carbocation. This carbon here is what's going to be attacked. So this carbon has three hydrogens. And so what's going to occur is that this is a carbocation. So this is the second step. The HOSO4, your extra or excess material, this has an extra electrons. It will attack the hydrogen, and this hydrogen bond will form a double bond, and our product would look like this. An alkene will be formed, and this will be our product. Do you see how it grabbed the electrons from the excess, or from our reactant will grab the hydrogen? Or you could have the OH or H2O group that could grab the hydrogen. It doesn't matter what grabs the hydrogen. all we need to know is that the hydrogen is grabbed and pulled off the molecule, and it fixes the carbocation solution by making a double bond here. So both this carbon's happy and this carbon's happy because they both will have 4 bonds. This carbon's happy and this carbon's happy because this carbon still has the 2 hydrogens and this one has the 1, 2, 3, 4 carbons. So that's an example of an E1 elimination. Okay, now let's try to do another problem, and I want you guys to try it on your own and see if you guys could figure out if it's E1 or E2 and how the mechanism looks. So problem is going to be, let me grab a problem sheet. Our problem will be, it's taking so long, guys. So I'll skip ahead later in the video. So guys, so this is your problem. Go ahead and pause the video, and okay, hopefully you guys have covered what a norborane structure is and what it is and what and it looks like a ship, honestly, but what it is, it's a cyclic ring. So so welcome back, guys. All right, so so I'm gonna show you guys how to do this and how to figure out is it E1, is it E2. So it might be kind of obvious, but this is a bulky or is it a weak base? So this is a bulky base. Let me change the color up. This is a bulky base. Bulky. And bulky bases automatically show that we're going to do an E2. Elimination 2. So bulky. So for here, what we're going to do, if we know K is a metal, so that crosses it out and that makes this a negative automatically. And for E2, everything happens at once. So this is going to be obviously the leaving group because it's a halogen and chlorine likes to leave. So this is going to leave here. So let's see, this is going to kick this off. And then the attached hydrogens here, what will happen? So the attached hydrogens here, this will grab onto one of these, or the chlorine could grab one of these. Either way. And once that happens, where does this bond go? It goes right here. So what's going to happen? So, put that better. I'm just going to go right here. So what structure is formed is we're going to have something that looks like this. Sorry, so I gave it extra. So a carbon here, and a double bond. That's our alkene. So E2 and E1 both form alkenes. I hope you guys noticed that. Formed. So what happened here is it all happened at once. So your leaving group is going to leave. This is your chlorine is your leaving group. And it left, so we have, this is one product plus your byproduct. So it left, forming a cation. This would become not a carbocation because it never has enough time to be considered a carbocation, but a plus charge is here, which is why the reactant would grab a hydrogen, and that hydrogen bond, or the bond here, would go onto the carbon, into that carbon bond, forming the alkene. So that would be your answer. So it was a big looking problem. It looked kind of scary, but it's the same concept as the one before, just everything happens at once. There's no 2 steps. It's just this answer to this answer. That's the mechanism. It's quick. So it's pretty easy. This is a byproduct. So we'll go over one more and see if you guys could get it. And I'll do an easy one. But it's pretty easy. The idea is easy. You're eliminating the leaving group, and you're adding. You're taking a hydrogen from a neighboring carbon and making an alkene. So let's try one more out. Okay. So what is formed? How do we do this? Is it elimination 1 or is it elimination 2? What do we know about OH? Well, OH is a weak base. It's a weak base, so that kind of puts it in the genre of S or E1. So we're also connected to a 1', 2', 3'. So we're on a 3' carbon, and it's a weak base. So that gives us an E1, elimination 1. And so what happens? How do we form a carbocation, and what do we do? So I'm going to go ahead and show you guys how to do this. So the Br is here. It's going to get kicked off, because who wants a halogen anyway? And then this would be our first product. So a carbocation is thus formed. Here's our carbocation formed. Okay, and we have a side product right now of a Br minus. Okay, well the OH is better attachment group, so the OH will attack. The OH group is also, so we have both these two here. So we have Br minus and an OH minus. And then we also have hydrogens attached to this carbon, this carbon, and this. So which hydrogen would get pulled? Well, we can pull from any of these hydrogens really. The only hydrogen we cannot pull from is the carbon on. Remember, that elimination, you're pulling from a neighboring carbon's hydrogen. That's very important. You're pulling from a neighboring carbon's hydrogen, not to fix the carbocation. So let's just say this bottom one, we're going to use this carbon here. And how come OH doesn't go up on here? Well, because OH isn't really, it's a good leading group too. So OH would instead grab this hydrogen to form water, or the Br, the bromine could also grab the hydrogen too. So you could pick whichever nucleophile you want, and then this bond will go right into there, thus forming an alkene. Once again, an alkene is formed. Then you're going to have a structure that looks like this. And that would be your answer. And it would be an E1 elimination. So guys, I hope this makes sense to you. I mean, you're really doing the same kind of stuff, same mechanism, same stuff. So for this one, you have E1 and E2. E1 is mostly weak bases, and E1 is weak bases. So anything that's a weak base is E1. E2 is bulky bases, so if it's a bulky base, you're doing E2. E1 requires 2 steps, a carbocation is formed. E1 is 2 steps, a carbocation is formed. E2 is 1 step, and it happens so quick. And another thing I forgot to mention, but in E2 reactions, or E2 reactions, it can attach from the backside. So you're gonna have to use you're gonna have to also put the stereochemistry. So you're gonna have to put one product wedged and one product dashed. I forgot to add that. I'm gonna put that on as a note or side piece, but that's also pretty important. And an alkene is always formed. So you're either gonna form an alkene or an alkyne. So that's either a double bond or triple bond, and you're taking a hydrogen from a neighboring carbon. So you're not taking from the same carbon, you're taking from a neighboring carbon. So yeah, that's pretty much, and you're eliminating a group. So you're not necessarily eliminating it, but it does leave. So this bromine leaved, and it could attach to that hydrogen. So guys, thank you guys for tuning in. My name is Adam, the science tutor, and email me if you have any questions. Please leave any problems on the bottom if you want me to work it out in future videos. And just please subscribe, please like, and spread it to your friends. Thank you guys.